Hey guys, welcome back to a new video. This session will be entirely devoted to solving this particular integral. Now, finding the solution will heavily rely on using integration by parts. So if you're not familiar with this concept, I will put a link to my video specifically on this topic in the description. The integral we'll be solving here is the integral of sine to the power of n. And we denote this integral as I subscript n, where this n can be any number you like. It could be 1 or 2, in which case we already know how to solve it. In the case of n is equal to 1, it simply becomes a basic integral. And for n is equal to 2, we can simply use goniometric formulas to get the right result. However, n could also be 6 or 11, which are much less straightforward to solve. Therefore, we will solve this integral step by step for a general n. And in the end, we will end up with a solution in which you can simply plug in your specific number n. So let's now get into the solution. Let's first, for good measure, rewrite the integral that we're trying to solve. So the sine to the power of n of x dx. And our first step will be to rewrite this sine to the power of n as sine to the power of n minus 1 of x times the sine of x. And we do not forget this dx. And we see, of course, that in this step, we use that x to the power of a times x to the power of b is equal to x to the power of a plus b. So if these x's are the same, we can simply add the exponents, which is what we did here for the sine of x. And now comes the most crucial step in our solution, which is to solve this integral of the product of two functions by using the method of integration by parts. And for this method, we have to first identify two functions, so f of x and g prime of x. And if this is not entirely clear to you, I gladly refer you to the video where I go into detail on the method of integration by parts. For f of x in our case, we will use the sine to the power of n minus 1 of x, which leads to f prime of x, so the derivative of this function to x, to be equal to n minus 1 of the sine of n minus 2 of x, so simply deriving this power of the sine of x, which brings this power in front of the sine of x, and dropping the power by 1. But we have to be careful here and also take the chain rule into account, and then also derive the sine of x. And this will give us the cosine of x using the chain rule of derivation. For g prime of x, we of course are left with the sine of x, which is the other function in our integral. And for this to get to g of x, we need to perform the antiderivative, which in this case is very simple. It simply becomes minus the cosine of x. Why is this? Because if we derive minus the cosine of x, we get the sine of x. And with these ingredients, we can use the formula for integration by parts. We know that this integral can then be written as the product of f of x and g of x, which becomes the sine of n minus 1 of x times minus cosine of x. And then a second term, which will be the integral, where we need f prime of x and g of x. So g of x will be minus the cosine of x, and f prime of x will be n minus 1 times the sine to the power n minus 2 of x times the cosine of x dx, which is simply this function multiplied with this function. And at this point, the hardest part is already done, because from here on out, we will only be using some algebraic manipulations to get to our result. Let me first rewrite what we already have now. So we have minus the cosine of x times the sine to the power n minus 1 of x. These two minus signs combine to become a plus sign, so plus the integral. This cosine and this cosine we take together, so this product becomes a cosine squared of x. This constant term we just leave unchanged, and then we finally have this sine to the power of n minus 2 of x dx. And from here on out, we'll be mainly focusing on manipulations on this integral. So I will actually be copying this first term in front of the integral because we will be leaving it unaltered for quite a while. And so instead of rewriting it all the time, I will just copy and paste it. So this will be equal to, like I said, this first term, which I will just paste in front of it, plus the integral. This constant factor can be put in front of the integral because it is not x dependent. So we have n minus 1 times the integral, and then this cosine squared of x we will actually write as 1 minus the sine squared of x. And this simply comes from the fact that cosine squared of x plus sine squared of x is equal to 1. This is this famous geometric formula. And of course, we cannot forget this sine to the power of n minus 2 of x dx, which we leave unaltered for now. This is equal to, again, pasting this term in front of the integral, which we leave unchanged for now, plus n minus 1 times, and what we're going to do now is to multiply this sine to the power of n minus 2 with both of these terms inside of these brackets, which means we will get an integral of the subtraction of two terms, which means that we will effectively get two integrals. So this first integral we get from multiplying this sine to the power of n minus 2 with this 1. So we get the integral of sine to the power of n minus 2 of x dx. The second term, which has a minus sign in front of it, we will get by multiplying this sine to the power of n minus 2 with this sine squared, which will then of course simply become sine to the power of n x dx, again using this formula where we have sine squared of x and sine to the power of n minus 2, and n minus 2 plus 2 is simply equal to n. So we have our two integrals. Rewriting this even further, we get again this first term, which we copy and paste, plus n minus 1 times these two integrals. And at this point, we want to rewrite these two integrals in the form of this in, because we rewritten the integral that we want to solve, the integral of sine to the power of n, as in. So we can now write this integral of the sine to the power of n minus 2 as being in minus 2, because the power of the sine inside of the integral is n minus 2. Likewise, we see that we actually have the integral that we're trying to solve here, the integral of the sine to the power of n. So this will simply be I to the power of n. And this is why this formula is called a recursion formula, because we see that the integral that we're trying to solve, in, comes back in our solution itself. We have in again here. So rewriting this, and to get an overview, we have that in, so the integral that we want to solve, this part, is simply equal to minus the cosine of x times the sine to the power n minus 1 of x plus n minus 1 times y n minus 2 minus n minus 1 times yn. And this is now an equation that we will rewrite a bit in order to get a formula that in is equal to something. So let's do some basic manipulations right now. What we will first do is get this term with a minus sign in front of it to the other side of the equality sign. So we get in plus n minus 1 times in is equal to minus the cosine of x times the sine to the power of n minus 1 of x plus n minus 1 times in minus 2. Taking these two terms together, we see that we get n times in is equal to n minus 1 times in minus 2. So I just swap these two terms here, minus the cosine of x times the sine to the power n minus 1 of x. And now you see that we're almost there, because we now simply divide both sides of the equality sign by n. And we get that in, so the integral that we're trying to solve, is equal to n minus 1 divided by n times in minus 2 minus 1 over n times the cosine of x times the sine to the power of n minus 1 of x. And this is actually our final result. And if we rewrite this result in terms of our initial integral instead of the notation with these i's, we get that the integral of the sine to the power of n of x dx is equal to n minus 1 divided by n times the integral of sine to the power of n minus 2 of x dx minus 1 over n times the cosine of x times the sine to the power of n minus 1 of x. And this is actually quite an extended formula. And we see that for any n that we have in our integral now, we can simply fill in n in all of these terms and we will get a solution. So how do we now actually use this formula to solve an integral with sine to the power of whatever number? And to do this, we will be looking at an example. Let's say that we want to calculate the integral of the sine to the power of 6 of x dx. Well, we see that n in this case is equal to 6. So we just fill in n is equal to 6 in this formula. So we get 6 minus 1 divided by 6 times the integral of sine to the power of 6 minus 2 of x dx minus 1 over 6 times the cosine of x times sine to the power of 5x. This of course then becomes equal to 5 divided by 6 times the integral of sine to the power of 4 of x dx minus 1 over 6 times cosine of x times the sine to the power of 5 of x. And this is the first iteration. What we did now is reduce this integral of sine to the power of 6 to an integral with sine to the power of 4. But now again, we can use the formula that we found to also solve this integral. So we get 5 divided by 6 times this integral. And we see here that n is equal to 4, which can then also be filled in this formula. So we get 4 minus 1 divided by 4 times the integral of sine to the power 4 minus 2 of x dx minus 1 over 4 times the cosine of x times the sine of n minus 1, which in this case becomes to the power of 3 of x. And of course we should not forget this term here, which we just copy. So 1 over 6 times the cosine of x times the sine to the power of 5 of x. And as an overview, so we first reduced this power of 6 of a sine to this integral of a power of 4. And now we again reduce this integral of the sine to the power of 4 to the integral of the sine to the power of 2, of which we just know the result. So we can rewrite this to get an eventual result of 5 divided by 6 times 3 divided by 4 times the integral of the sine squared of x dx minus 1 over 4 cosine of x times the sine to the power of 3 of x minus 1 over 6 times the cosine of x times the sine to the power of 5 times x. And this is actually our final result, because we know from in the beginning of this video that this integral is actually 1/2 times x minus 1/4 times the sine of 2x, and we get a result where we no longer have integrals. So we only have x's, sines of 2x, cosine of x, sine to the power of 3 of x, sine to the power of 5 of x, and the cosine of x. And this is exactly what we want if you want to solve an integral. So we solved the integral of sine to the power of 6 of x, and we've written it as a combination of sines and cosines of x. This brings us to the end of this video. And I hope that you now have a better grasp on how to use recursive formulas and that you now know what they are. As always, if you have any questions or suggestions for future topics, let me know in the comment section below. If you learned something, give the video a thumbs up, and if you want to get notified by future releases, consider subscribing. And with that, I thank you for watching, and I will see you guys in the next one. Bye.